Hello there, I'm Pooja. Welcome back to Periodic Chemistry. In this video, we'll learn how to use Nernst equation to find cell potentials. If you're new to my channel and haven't subscribed yet, please subscribe and hit the bell icon to get notified about my upcoming videos. Okay, so let's start. Let's take a quick look on various forms of Nernst equation and then we can go for numericals. Let's consider a general equation. A plus B gives C plus D, where capital A and capital B are the reactants, capital C and capital D are the products, and small a, B, C, D are the coefficients. Let's look at the first form of Nernst equation. E cell is equal to E naught cell minus RT upon NF ln concentration of products divided by reactants raised to their coefficients. So, it's clear that Nernst equation gives a relationship between the standard cell potential and the cell potentials. We have seen the difference between these two cell potentials in my previous video. If you haven't watched my previous video, I request you to please watch that for clear understanding of the concepts in this video. So what are these each terms in this equation? N is mole of electrons, F is Faraday, which is equal to 96500 coulombs per mole of electron. Temperature is T and it is in Kelvin. It is very important to convert the temperature in Kelvin. And R is a gas constant which is equal to 8.314 joule per Kelvin per mole. So we can convert the natural log into a log to the base 10. So when we convert that, our equation turns to be E cell is equal to E naught cell minus 2.303 RT upon NF log to the base 10 concentration of product divided by reactant raised to the coefficients. Now, if we plug the values of temperature, Faraday's and gas constant, then we get a new form of equation which is E cell is equal to E naught cell minus 0.0592 upon N log to the base 10 concentration of products divided by reactants raised to their coefficients. Remember the temperature here is 25 degrees Celsius, which is converted into Kelvins. So whenever the temperature is given as 25 degrees Celsius, we can directly use this third formula. So general, we can write this equation as E cell is equal to E naught cell minus 0.0592 upon N log to the base 10 concentration of product divided by the reactants. Let's solve 5th MCQ from Maharashtra State Board 12th Standard Science textbook. I'll read out the question for you. For the cell Pb in Pb plus 2 ions of 1 molar and Ag in Ag plus 2 ions of 1 molar, if the concentration of an ion in the anode compartment is increased by a factor of 10, the EMF of cell will be. So the given terms are the short cell notation and we need to find EMF of cell. We will be using Nernst equation to solve this problem. Let's see the solution step by step. First, we need to determine whether it is in galvanic cell or electrolytic cell. It is clear that it is in galvanic cell because we can see a double line representing a salt bridge. And we know that for galvanic cell, it is left oxidation anode negative. Therefore, left electrode lead will be an anode while right electrode silver will be a cathode. Let's write the half cell reactions for this. Pb will be undergoing oxidation to give Pb plus 2 electrons and Ag will be undergoing reduction to give Ag solid. We need to manipulate these reactions to make the electrons equal because we can see that both the ions have different charge. To decide the value of N, we need to make the number of electrons equal. So, I have multiplied first equation by 1 and second equation by 2. Therefore, the number of electrons will be equal and after adding these equations, we get our overall reaction Pb plus 2Ag plus giving Pb plus 2 Ag solid. Therefore, value of N will be equal to 2. And it is also clear from this equation that Pb plus 2 are the products while Ag plus 2 ions are the reactants. Let's first calculate E cell for the original reaction, where the concentration of reactants and products was 1 molar. Let's plug the values in the equation. E cell is equal to E naught cell minus 0.0592 upon N log to the base 10 concentration of Pb plus 2 divided by concentration of Ag plus. We know that the concentration is 1 molar, and therefore we get log 10 as 0, and this whole term on right hand side, that is 0.0592 upon N into 0, will become equal to 0, and therefore E cell is equal to E naught cell. That is, cell potential is equal to the standard cell potential. Now let's calculate when the concentration of Pb plus 2 is increased by the factor of 10. Original concentration is 1 molar and increased by the factor of 10. So we will multiply it by 10 and we get our new concentration as 10 molar, while the concentration of Ag plus remains 1 molar as it is. Now let's again plug the values in the same equation. Value for N is 2. We have seen it earlier. So we get log 10 as 1, and after calculating we get E cell is equal to E naught cell minus 0.0296. Therefore, we can clearly say that EMF of cell will decrease by 0.0296 from the original EMF. Alright, so this was all about this part of electrochemistry. For further concepts, you can watch my other videos and also my previous ones. Please give your feedback and don't forget to hit the bell icon. Like, share, subscribe, and comment. Till then, thank you and stay safe.